Reporting category 1 is properties and attributes of functions. So we're going to start by going over a bunch of vocabulary. So the first vocabulary we have is domain. Domain is the x values for a function. And we write the x values for our function either in interval notation or in inequality notation. So we're going to look at both. And then range is the y values, and again, interval notation or inequality notation, and again, we're going to look at both. Continuous means that it is connected. When we talk about continuous, we mean graphs. So that means that the graphs are connected. It means that there's a starting point and ending point, and they are connected like that. Discrete means that they are not connected. When we talk about discrete, we talk more about scatter plots where it's points that are just kind of there. They're not connected. That's what discrete is. They're just random points that are not connected. The next section of vocabulary is on all the parent functions, and we have 8 main parent functions that we talk about in Algebra 2. So we're going to go through each one of those. We're going to look at what the graph looks like, what the equation is, and we're going to talk about domain and range and if there's any other special attributes. So the first one we're going to talk about is linear. Linear is y equals x. So linear is y equals x. And if we sketch a graph of y equals x, linear means that it's a straight line. So y equals x is a straight line through the origin, through 0, 0. The domain of this is all real numbers. The range is all real numbers as well, because there is no restriction to what the domain or the range could be. The domain goes on and on to the left and to the right in both directions. The range goes on and on, up and down, with no restriction. So in words, it's all real numbers, or we can write it with an interval, and as an interval, they both would be negative infinity, and they both get parentheses, negative infinity to positive infinity. And again, those are parentheses. The quadratic parent function is y equals x squared. Y equals x squared is the quadratic parent function, and when we graph it, because it's a quadratic, it makes a parabola. The parabola has a vertex at 0, 0, and it opens up. It is a U shape. That parabola is a U shape. The domain of that parabola is all real numbers because it goes on and on to the right and on to the left. Remember, I can write all real numbers or negative infinity to positive infinity, with both getting parentheses. The range of that parabola is not all real numbers because it doesn't go down into the negative y values. It's only in the positives. So it would be y has to be greater than or equal to 0. As an interval, it would be bracket 0. And the bracket is because it's sitting at the point 0. That's a set point where there's a closed circle. So 0 to infinity, and infinity has a parenthesis. So the next one is exponential. The exponential parent function that we use is y equals 2 to the x. Y equals 2 to the x. If we sketch the graph, it looks like this. So it's getting closer to the x-axis over here on the left and going up to the right. The domain is all real numbers, or negative infinity to positive infinity. The range, you'll notice our graph never touches that x-axis. So that means the range is y is greater than 0. Y is greater than 0. As an interval, it would be 0 to infinity, and both would get parentheses. Because that 0 is not equal, it gets a parenthesis. The logarithmic parent function is y equals log x. And if we sketch that graph, it ends up looking like this. That's the log parent function. The domain of it is x is greater than 0, because it doesn't actually touch 0, so it's x is greater than 0. As an interval, it's 0 to positive infinity. The range is all real numbers, which is negative infinity to positive infinity. The next one is the absolute value parent function. Absolute value parent function is y equals absolute value of x. The graph of the absolute value parent function is that V shape that sits at the origin. The domain, look at it, is all real numbers because it goes on in both directions. And I'm just going to write it as all real numbers this time. I'm not going to write the interval because we've done it so many other times. The range is y is greater than or equal to 0. This one I will go ahead and write the interval for. It's 0 with a bracket and then positive infinity with a parenthesis. The square root parent function is y equals the square root of x. If I draw the graph starts at 0, 0 and goes to the right in a little curve. The domain of it is the x's are greater than or equal to 0. Starts at 0 and it goes to the right. So x is greater than or equal to 0, or 0 to infinity, with 0 getting a bracket and infinity getting a parenthesis. The range is very similar, except the range is about the y's. So it's y is greater than or equal to 0, or 0 to infinity. The reciprocal and rational parent function, we've been talking about rational functions just recently. It's y equals 1 over x. The graph of that one has a curve in the first quadrant and a curve in the second, or in the third quadrant. So curve in the first, curve in the third. The domain for this one is different than the other ones that we've done. It goes from negative infinity to 0, and both of those have a parenthesis. That is this left part, from negative infinity to 0. The right part goes from 0 to infinity, with both getting parentheses. And in the middle, I'm going to put a U, and that U stands for union. It's putting those two pieces together. The range is very similar. I'm going to do the bottom part first. It goes from negative infinity to 0. And again, 0 gets a parenthesis in this case because there's not a set point there. And we have the union from 0 to positive infinity. Basically what that means for both of those domain and ranges is that x cannot be 0 and y cannot be 0. X can't be 0, y can't be 0. The domain could be anything else except for x equals 0. The range could be anything except y equals 0. Inverse function, there's two things we're going to write here for inverse function. The first is that for a graph, you reflect over y equals x. To find the inverse function of a graph, you reflect it over the line y equals x. For an equation, you switch the x and y. For an equation, you have to switch the x and y and then solve for y. That's how you get your inverse function. And the last vocabulary is scatter plots. For scatter plots, we talk about positive correlation meaning it increases. We talk about negative correlation, meaning it decreases. And we say no correlation when it's just kind of scattered. Okay, so for our questions, remember I told you in class that there were some pieces that were missing. So in this graph, in this problem number 1, the graph is what's missing. So I'll see if I can zoom in on that and get it a little bit bigger for you to see. Okay, so there's our graph. Our endpoints, that one is 2, 3. This one up here is 5, 8. This one is 11, 1. And this one is 13, 6. So you might need to pause the video for a second to copy that graph. You need to have all 4 of those endpoints on it so that we can answer the question that was there. Okay, so pause the video if you need to. So our question says, find the domain and the range and write it in both interval notation and inequality notation. So let's do domain first. We know domain is about our x's. So x's go from left to right. So look at the far left of our graph. On the far left of our graph, what's our x value? It's 2. What's our x value on the far right? It's 13. So the domain goes from 2 to 13. Now for interval notation, we have to think about what goes around both of those. Do they get parentheses or do they get brackets? And in this case, they both get brackets because they are set closed points. Because they are closed points, they get brackets. So that's the interval. The inequality, we write 2 and 13 with an x in the middle, and I leave that little bit of space. So for the inequality, we're saying 2 is what compared to all of those x values? 2 is less than or equal to all of those x's in that graph. All of those x's in that graph are also less than or equal to 13. And again, they both get the or equal to because of those closed circles. So I want you to take a second and try the range doing it the same way. The difference, though, with range is that it's the y's, and the y's go from the bottom to the top. So look at the bottom of the graph to the top of the graph. And so the range would be 1 to 8 with brackets around both, or 1 is less than or equal to y, less than or equal to 8. And that's it. Number 2. Number 2 says describe the transformation from f of x to g of x. And on your paper, f of x and g of x were left off, so copy both of those functions down. If you need to pause the video to copy it down, go ahead and do that. I'm going to keep on going though. The transformations from f of x to g of x. The first thing I'm going to notice is out here there's no number, and here there's a 3. So one place has no number, the other one has a 3. What does that 3 on the outside of the parentheses do to our graph? That 3 on the outside makes it stretch vertically. What it does to our graph is it pulls it from the top and the bottom, and it pulls it up, kind of like if I pulled you by your head and your feet and made you really super skinny. That's what it does to the graph. On the inside of the parentheses, it goes from -4 to +2. That is a difference of 6. It's a difference of adding 6. But when things are inside parentheses and you're adding 6 to it, that really means that you're moving to the left 6 places. Remember that inside parentheses, inside absolute value, inside radicals, it kind of messes with your head. It does the opposite of what you think it's going to do. On the outside, that -5 and -2 really means -5 and -2. That is an up and down movement. So if it was at -5 and now it's at -2, that means it moved up 3 places. So those are our transformations. It stretched vertically, went left 6 and up 3. Now problem number 3, you need to find the inverse of f of x equals 3x minus 1. That 3x minus 1 was left off your paper, so make sure you write that down. To find the inverse of an equation, we switch the x and y. Remember, f of x is the same thing as y, so I put x there and 3y minus 1. Then I have to solve for y. To solve for y, I add 1, so x plus 1 equals 3y. And this is just a normal linear equation, so x plus 1 equals 3y. I divide by 3, and those 3's cancel. So my inverse function, and I'm going to write it using inverse notation. The inverse function of x, this little f to the negative 1, that is inverse notation. The inverse function of x is x plus 1 over 3. And there's our answer. Okay, so our last question. You're given the following data values. You have to decide if the data is linear, quadratic, cubic, exponential. And you have to prove your answer with a graph. So again, these points were left off your paper, so take a minute, pause the video if you need to write those down. And then we're going to prove our answer with a graph. And so I'm going to look at those points. When I look at those points, I notice they're all positive. So I'm only going to draw the first quadrant of the graph. I only need that positive section because I have no negatives. So let's not take up the time to do the negatives. So I plot those points 1, 5, 2, 2, 3, 1, 5, 3, and 6, 5. When I look at those, is it linear? Linear means that it makes a straight line. Are those in a straight line? No, so it's not linear. Quadratic makes a parabola. If I follow those dots, does it make the shape of a parabola? Kind of, probably, so let's keep quadratic in our mind. Cubic is something that was left off the top part for vocabulary, so let's add it here. The cubic parent function is y equals x cubed. The cubic parent function as a graph goes up on the right and goes down on the left. Is that what this looks like? No, so it's not cubic. Exponential is the one that increases going to the right. Is that what this does? No, so it has to be quadratic. So remember, I'm going to be checking your paper, and all of these things I've written down I expect to see on your paper as well.